Assigning 1 million tasks a second to an autonomous machine simultaneously gives it the capacity to make 1 million catastrophic mistakes a second. Large language models, or LLMs, AI algorithms designed to process and generate text based on patterns in vast datasets, are inherently probabilistic. Their reasoning paths change dynamically and unpredictably with every input. Enterprise infrastructure operates on the exact opposite principle. Core systems demand absolute mathematical determinism, where a specific input must yield the exact same output every single time. Automotive engineers design high-performance braking systems to provide the structural control necessary to drive a vehicle at its absolute maximum speed. Without a deterministic containment layer, the speed of autonomous AI creates a massive, unquantifiable liability for the enterprise. We can observe the consequences of missing containment in the Model Context Protocol, or MCP, an open standard connecting AI models to external tools. It includes a sampling capability that allows an external server to proactively request an LLM completion from a client. This reverses the traditional client-driven interaction flow, granting external tools the direct ability to prompt and query internal AI models. This unmonitored sampling creates a precise attack vector, where compromised external servers can hijack conversations and execute resource theft. This dashboard shows the physical cost of rogue agent loops. Unmonitored sampling allows external servers to drain AI quotas, resulting in severe infrastructure strain. Hijacked conversations escalate rapidly into covert tool invocation, where agents perform unauthorized system modifications without explicit user consent. Relying on an agent's internal logic to self-police creates an infinite attack surface. Security must operate strictly outside the agent's brain. Aegis Shield provides that external security. It is a deterministic boundary layer, a zero-trust intercept gateway positioned directly between the agent's logic and the enterprise environment. The first layer of this intercept relies on the Aho-Karasik algorithm, a specialized string searching algorithm that locates elements of a finite set of strings within an input text simultaneously. It performs fast, local pattern matching to instantly identify and disintegrate prompt injection attempts. The second layer enforces payload containment using Zod, a TypeScript-first schema declaration and validation library. It guarantees that any data output matches expected API formats before execution can proceed. This settings panel displays how administrators customize these hard boundaries, hard-coding exact routing constraints to govern where an AI can and cannot send data. Pre-flight request scans and clipboard monitoring act as a final net, intercepting personally identifiable information before it leaves the edge workflow. The Shield intercept converts probabilistic AI intent into safe, deterministic enterprise execution. Once an action is deemed mathematically safe, how do we verify the identity of the AI attempting to execute it? The Multinex Visa protocol manages this verification. The system operates on an absolute root invariant. No visa, no execution. This diagram illustrates the protocol's core mechanism, the MNXS ID passport. Agents follow a 4-tier clearance hierarchy, restricting Level 1 visitors from kernel-level tools accessible to Level 4 sovereigns. Cross-organizational operations require a handshake sigil, an offline verifiable envelope using ED2559 public key signatures for fast, secure cryptographic verification. Cryptographic signatures strip bots of their ability to roam freely, regulating them into a structured workforce. Autonomous programs suffer from agent amnesia. Over the course of complex multi-day projects, they forget context and repeatedly make the same operational mistakes. The Ouroboros governance loop forces agents to reflect on outcomes before starting new tasks. These reflections write permanently into the sole journal. This append-only JSON-L ledger gives human overseers an exact, replayable history of the agent's reasoning and tool calls. Mandatory reflection combined with immutable logging translates opaque AI decisions into transparent, legally auditable evidence. As these agents move into the public sector, a distinct crisis of trust emerges, differentiating an officially sanctioned government agent from a malicious deepfake. The Public Sector Agent Registry Initiative bridges internal offline cryptographic sigils to public, verifiable formats using an ERC-721 token, a standardized smart contract used to create unique, non-fungible tokens on a blockchain. Through an integration with humanity.tech, the agent's public NFT badge links directly to the biological passport of a living human operator. This connection acts as a direct kill switch. If the human's biological passport is flagged for a policy violation, the Multinex control tower autonomously revokes the linked visa sigils. True accountability requires an end-to-end chain of custody that permanently anchors artificial intelligence to biological responsibility. The AI software economy is scaling rapidly, yet 95% of enterprises lack the foundational infrastructure to safely deploy agentic frameworks in a production environment. For irreversible actions, the system defaults to the user-agent bond, or UAB, a dual-signed attestation where both the human and the AI must cryptographically agree before executing a critical change. The complete stack operates together: the ARS runtime for orchestration, Airlock for organizational isolation, Shield for deterministic security, and Visa for identity. Enterprises must stop hoping their agents behave and start guaranteeing it mathematically. Multinex.ai/shield